The first presentation will be delivered by Anthony Smith on the use of transit ITS data for improving GO bus services. In the video, I noticed that the first GO bus service was introduced in the mid-70s. I didn't actually know that. So it's been around for quite some time. It's a very unique system because the buses travel on freeways as well as city streets in a very huge service area in the Greater Toronto area. So very shortly we'll hear from Anthony, and then that will be followed by a presentation by Jasmine Iftikhari from the TTC. And the third session will be by Howard Chang from GRT, not too far from Toronto, from Waterloo. There's a lot of exciting stuff happening there. So we're very much looking forward to all three presentations. So, so Anthony, if you wish to share your screen and get ready to start. Anthony? I think you're muted. Okay, perfect.
Hello.
Yeah.
Thank you very much. You're right on time. Just give me 1 second and I'll put up the presentation.
Sure. Yeah.
All right. Can you see that?
Not yet.
Not yet.
Sorry.
So while it's appearing, so Anthony is a senior planning officer with in the planning and development department with METROLINX, and he's going to talk to us. Maybe I'll leave it to him to tell us what exactly he's.
Sure. Thank you so much.
Thank you.
All right. Thank you. It's really an honor to be here, and fantastic morning. I also have to say the music in that video was great. I was thinking about dancing. So today I just wanted to share a little bit about what METROLINX has been doing using automated data. And I titled this talk Finding the Signal in the Noise, because I think it's easy to get lost in a lot of these data sets and forget why we are doing what we're doing. And ultimately for us, the goal is to improve customer experience. And a secondary goal is to improve the efficiency and effectiveness of service delivery. So we'll share a few examples of what we're doing. There's really three sections: quick introduction to METROLINX and Go Transit, just for those who are not familiar. And then I'll run through the use of GTFS, Presto BI, which is our fare card system, and APC, which is kind of the main focus. And I'd like to close with some discussion on regional collaboration. So for those who are not aware, I think the video gave a good introduction, but METROLINX has two large roles. One is as a regional transit agency. So our business lines are Go Transit, which is Go Bus and Go Rail, as well as Up Express, which is their airport service. And we operate the Presto fare card system, which is used by many agencies. And then the secondary role is as a regional authority, we work with our partners who deliver local transit and try to help coordinate and plan long-term, so things like the regional transportation plan. So why are we here? First of all, our primary goal, as I said before, is to increase ridership on, my specific focus is Go Transit, but broader speaking across the region, and also ensure safe and effective service delivery. So using data to inform that decision-making process. And using ITS data, specifically, we're looking at Presto and the AVL systems on our buses linked to the automatic passenger counters. We have about 400 vehicles in our fleet. So it's not as large as TTC by any means, but there are quite a number of vehicles and very long highway-based trips. So quite a number of kilometers traveled. So at the end of the day, we want to monitor customer demand on these routes, optimize our service deployment to align the demand, service with demand, and ensure connections with our regional partners to have smooth travel experiences. So on the right, you can see our COVID drop. It's kind of the standard graph for a lot of agencies. Like many, our bus demand actually stayed a little higher than our rail demand. So we are starting to bounce back. But the goal here is to take data like that and transform it into something we can make decisions and actually drive change. So I like this analogy, turning data into something we can absorb, just like ice into water. So first of all, just briefly talk about GTFS, because it, for us, represents the easiest way to see what all our different transit partners are doing. So this is all the routes across the region shown as kind of one network, colored by different agency. So we are working to collaborate and increase the connectivity between these networks, using transfer time between different modes, for example, and a large initiative is fare integration. So working with the Ministry of Transportation and the provincial government, I think that is a big focus for our service and increasing the fare and equity of our system. That is really one of the big goals. But in kind of the more detailed technical side, I just wanted to share this little example I made using some open source tools to say, you know, the GTFS data is great as a raw data set. We can do a lot of cool analysis with it, but we really need simple metrics that this is every go bus and rail trip in the region. But at the bottom, it shows the number of vehicles on the road. And it's really simple things like this, like how many trips are out there? Where are they? Which corridors are being delayed? And where is the demand changing over time? So if we can get that level of granularity and communicate that to our senior decision makers, then we can actually have change. So the Presto BI data sets, I'll say briefly, because this is mostly focused on rail. I know the focus here is bus, but I just wanted to highlight that we do have some interesting dashboards built in Tableau, where we can look at ridership over different stations, over different corridors, over the whole system, and track the changes over time. So this shows Long Branch, which is my home station, and you can see each line stacks up year-over-year comparison. So it's really important. The way we structured the visual actually allows month-to-month comparisons and kind of taking the seasonality out of the data. So simple things that really help drive decision-making. We also summarize these data sets into a regional dashboard, which is published on our METROLINX blog. We recently shared this with the COVID impacts of our rail stations. So if you have time, go check it out. I'm not going to dwell on this today, but it is a really useful, simple tool to communicate these data that are quite complicated to a senior decision maker who can just open a PDF, zoom into a station, and explore things like where it was construction, where's the parking issues, where's their capacity or service level changes. So we're trying to connect all those dots to inform decision making. Similarly, we have some behind the scenes dashboards, like this is a Up Express data set. We link together different things like crowding, time of day, different tickets. So this is another example of a dashboard that can integrate many different data sets. And finally, on the Presto side, I just wanted to share this as a kind of cool example of how we can unpack some hidden data, things like the geographic locations of all the different taps. And look here on the top left is where GO Transit boardings occur. And these are specifically customers who then transfer to a TTC station or bus. So at the end of the day, these pink dots are where the customers come back onto the TTC system. So in the end, what we can do is actually connect those two travel paths and identify where the transfers occurred between those two systems. So as a regional authority looking at fare integration, for example, it's really important to understand that kind of not only the origin and destination, but kind of those gates that people pass through on their journey. So finally, I'll just dive into the APC data. And this is really exciting. I think some of the newest examples, we saw such great information this morning. But just for our perspective, you know, it's a great source of understanding at the trip level, at the route level, or also at the stop level where customers are getting on and off our buses. So Union Station, Square One, Yorkdale, those are kind of our biggest hubs. And then we can also drill down by different routes, different times of day, etc. We didn't have these tools a few years ago. So this is really kind of exciting new data, and also putting it in, this is Tableau, but we're actually shifting. Our newest platform is PowerBI, and our organization's just migrated to this. It's still not available to all users, but it will eventually be a click away. Any user in the organization can click here and track our ridership over time. And providing the data in the way people need it is really the goal here. So breaking it out by day, by corridor, and by route kind of answers the questions people typically ask. So here at the bottom, you can see, for example, Route 70 has only declined 4% year over year, which you may think is incredible. It's doing really well despite COVID. However, it's because you have to look further in the data and see that the trips have actually doubled. So we took some rail service off this corridor and we've shifted that demand onto the bus. And that kind of explains the story here. So there is a lot of insight behind the data that we need to appreciate. Similarly, we can look at monthly trends, total boardings, total trips. You can see we've kept service levels fairly high despite the drop in ridership. And then also the scheduled service hours and scheduled service kilometers. So just providing this information in a useful format to decision makers. And similarly, I think this is really the important thing. Different people ask different questions. One day they ask month, the next day they ask day. So providing a second dashboard that's just the next page away, that this shows average daily data sets. So scheduled trips, broken out by day of the week because we have several different service patterns. And the one I really wanted to highlight is on the top right, passenger kilometers per scheduled service hour. We shorten that and call it PKH. It's essentially an effectiveness measure. It balances the amount of service we're deploying to the travel distance of our customers. And it kind of makes an index out of those. So we can see how much the service we deploy is actually being used. And our goal obviously is to increase that utilization, but balance it to avoid crowding and other negative impacts. So on the bottom, we also have the average boardings per trip, which is another one of our kind of KPIs, performance measures. And just in the interest of time, I'll skim through that, but you can go back or ask me questions. We do sort of in the process of developing some other pages on this dashboard. One of them is related to max loads. So looking at average max loads by day of week or by time of day. And then you can drill down by route and provide sort of those deep dive questions if you need that. However, this Power BI platform stops here. You can only get down to kind of the route level. There's one final thing I wanted to explore, which is TRANSIFY.CITY. It's a new app that's being developed by a former intern of METROLINX. He's developing the software on his own, but we've been testing it, and it provides a really interesting deep dive into the APC data. So you can filter on an individual day or route, and then do a deep dive looking at different stop boardings or different routes on the right. You can see the boardings across, the cumulative load across the journey and compare different trips through the day. And I'll just say, there's also the ability to look at boardings and lightings, looking at cumulative load across the journey, and also comparing different time points. So this is pre-COVID. You can see a lot of boardings at Yorkdale Bus Terminal, and that's obviously a mall that might have been highly impacted by COVID. So the drop in boardings at Yorkdale was quite a bit more substantial than the York Mills Bus Terminal, which was about 50% higher than Yorkdale after COVID, even though they were equal before COVID. So these kinds of stories, we can look a little closer, start to get trip level and individual stop level data. So TRANSIFY.CITY, it's actually a free platform. It's a fantastic user interface. Check it out if you're interested. So next steps, I just wanted to say, I think we all acknowledge there's challenges in data compatibility, understanding, different agencies have different formats, but also internally, we have different teams working on different questions, but we do want to build sort of universal tools that help the whole organization move in the same direction. So I think ultimately we do want to have this kind of regional data observatory. It is actually an action from the Regional Transportation Plan. There was I think section 8.3 or something, identifying this type of a regional strategy where we can all collaborate more effectively. And I think TAL is a great platform to kickstart some of this work. So the two areas I want to leave you with as kind of next steps. First of all, technology, identifying, I don't think we've talked about this much today, but the technology that drives the signal priority across the region. We want to make sure we understand what different agencies are doing, planning as we move towards these BRT corridors. We're rolling out several large BRT projects, and we want to work collaboratively as the region. And also, as our number of trips expand, some of our bus bays are actually getting quite crowded. So wondering, at Union Station, for example, we've implemented a new dynamic bus-based system. It's on demand, so the bus rolls up and a QR code is scanned, and it tells the bus where to go. And customers then board, just like an airport, they go to the gate that they've been assigned. So it's an interesting new technology we're just starting to roll out. And finally, on tools, I think this is where we're really excited to work collaboratively. Things like cellular data, Wi-Fi, and GPS that are available now. How can we, instead of looking at this at an agency level, potentially, like we saw earlier, work on a regional scale to understand travel patterns using cellular data that can then filter into our travel demand modeling and ultimately the business cases for new projects. The second and final thing I'll say is GTFS and some of the real-time information feeds like Willem shared earlier have a lot of value. And I think we haven't fully unpacked the value in our region to monitor certain levels over time, look at things like cumulative trips on a corridor and understand not just one agency, but if you stack on top all the different trips, how many trips are there, what's the headway per hour, and is there delays that are chronic that we can address through broader corridor level interventions? And then also understanding connectivity. And I think this is where that service integration is really critical. Where our border exists, it doesn't really mean the customer stops there. We need to ensure those transfers are really smooth and seamless, as well as between modes, things like our GO stations. When we have a local bus arrive, we want to make sure it's a seamless transfer for the GO customer as well. So those are kind of the final thoughts, maybe open for discussion. Just like to thank everyone for your time. We're certainly interested in further dialogue, so send me an email. And I want to also acknowledge this is just our work from planning, design, and sponsorship, or PDS. We're kind of one part of METROLINX, but some of this work was from the marketing division as well as the operations division. And ultimately, we are one group, but there's several silos that are all kind of working on different projects. So really thank you to the whole organization. And I'll just leave it there.
Thank you so much, Anthony. Very, very interesting work. A lot of interesting developments. I'm quite intrigued by the Regional Data Observatory. That sounds like a worthwhile effort to do, for sure. Our experience with the work we're doing in the US, it's been really presenting us with a lot of challenges when there's no standardization of data in the same region. So I'm happy that you're undertaking this effort. So I'll open it now for questions. We have a few minutes for questions. Maybe I'll kick it off. You mentioned service integration among agencies. Is there any effort to help with the sort of schedule optimization, like between different agencies at the border, so that we have more seamless transfers?
Yeah, I think there's certainly a lot of discussions going on. We have a regional table of collaboration. It's the Transit Leaders Forum, which I think is monthly. My director attends, and working on that scheduling issue. But there's a fine line. We don't want to overstep our authority and kind of give marching orders to different agencies. So we are working collaboratively, and actually in the spring, we're putting together what we're calling a 4-pillar plan for service integration. And that will include several strategic actions that we can kind of work together with our partners to implement. So in addition, the one other thing is that schedule timing at GO stations. We're very interested in optimizing when those transfers occur. So we're actually building out a tool using GTFS data. We already have one way of measuring the schedule timing of those transfers, but we're now working in real time, looking back historically at real-time feeds to see if the schedule is actually accurate or if the bus is, always 10 minutes late and the people miss the train. So those are kind of two different areas.
Okay, thank you. Do you have other questions?
I see one question from Omar.
Oh, okay, in the chat box.
So maybe I'll just read it. Does METROLINX rely on Presto data for OD pairs? If so, how do they account for limitations such as no tap on exit? That's a great question. So that is one of the downsides of the way typically the Presto system works across the region. There's no tap off on many of our partners. METROLINX or Go Transit actually does have a tap off for a majority of our trips because we have a fare by distance policy. Or it's actually a zone-based fare by distance. And so we have some OD pairs, although it's not really representative. A lot of our fares are, they have prepaid trips. So we miss a lot of those because they're in a different data set. They don't link back to our Presto BI platform. So we are, I think, through the trip reconstruction model, looking at individual anonymized transaction data, we can link sequences of transfers and look at where the morning tap is and the afternoon tap and try to connect those two dots on the map. The final wrinkle is that we don't always have accurate GPS coordinates for each fare device. So we actually, as part of the Presto 2.0 rollout, in the next 2 or 3 years, we should have a device refresh, which will enable a lot more GPS-enabled data collection.
Okay, we have a few more questions on the chat box. First from Brandon, he's asking about the difference between using GTFS RT versus analyzing AVL data directly.
Absolutely. So that's a great question. We've just started a project working on this, looking at corridor level delays, potentially using using GTFS real time. The big benefit for us is for Go Transit, we use our OTP measures are all based on our CAD AVL system. However, when we try to look broader beyond the Go Transit network, trying to get AVL system data from 12 different transit agencies and collaborate could be quite a challenge. So we're just kind of testing the idea of looking at if we archived all the data for all the real-time feeds, acknowledging TTC as a different next best platform, and merge that all together, how could we come up with not a, it's not a performance scorecard. We just want to understand where the delays are happening and then share that with our partners so we can all work together to resolve those issues.
Okay, Justin is asking next when METROLINX plans to release, or if METROLINX plans to release the boarding alighting dataset as part of its open data initiative.
Yeah, this is really an exciting area. I've been at METROLINX 4 years and I've been involved in open data since the start. We have actually been highly motivated. There is a provincial directive to share open data, and we've recently updated our first ever open data portal with 4 data sets, including the GIS network for the region. The boardings, alightings, currently it's just that PDF map that I showed. And at a bus level, we don't have any information. So part of the work we're doing behind the scenes is there's an open data working group, and we have a long list of over 200 data sets that we're reviewing. And boardings, alightings is absolutely on the short list. And we're trying to get through the approvals. There is a steering committee that signs off on these data sets, but I'll just say informally, it's in the short list and we're working towards it. The key question is what level of aggregation? So would it be by routes, by day, by trip, by month, whether it's just total by routes, by month, it doesn't give you quite the same level of detail that you would need for crowding analysis. So we're working on it. I'll just say that.
Okay, one last question before we move on to the next presentation by Wendy about the regional analytics database. If you can just say a few more things about it.
I should say this is not, it's really just an item in the RTP at this point. It's an action, and that is not currently, we don't have a mandate from MTO to invest heavily into this area. We're primarily at this point focused on optimizing Go Transit operations and customer experience. Building out that kind of regional platform and observatory, as it's called, is certainly something we're interested in, but I think platforms like TAL are a great location to really push this agenda forward, because you kind of have almost neutrality in your objective in a way. So there's no different political or interests involved. So I think at the end of the day, you're looking at GTFS and being more transparent with our open data platform are the first 2 actions that we're pursuing.
Yeah, and definitely TAL will be very happy to play this role Okay, so thank you very much, Anthony, and it's a great presentation. So there's one more question if you wish to perhaps answer it in the chat box, but just in the interest of time, our next presenter is Jasmine Iftikhari from the TTC. Jasmine is a service planning analyst with the Research and Analytics group of the TTC. Jasmine, please share your screen and you can start your presentation.
Thank you, sure. Can you see my screen now?
Yes, we can.
Okay, great. Hi, everyone. My name is Jasmine Iftikhari. I'm a service planning analyst at the Research and Analytics department here at the TTC. And today I'm here to talk to you about how the TTC has been using analytics tools and ITS data to support service, and also to give you more insight into our customers' changing mobility patterns during the COVID-19 pandemic. To begin with, I will give a quick overview of the pandemic here in Toronto, how it challenged and impacted the way we provide service and how we responded to the challenges posed by the special nature of the pandemic. I will then walk you through some of the ways we've been using our APC data in the recent months. One of the tools our department developed and started using since the beginning of the COVID-19 pandemic was the APC Ridership tool, which is a visual tool that shows customer demand and hotspots across the city. I will then spend some time to talk about the use of the train weight data and how that data was used to inform the recent subway closure. We have also been using APC data to develop a crowding dashboard, which is used by our colleagues at the transit control. And last but not least, we'll switch gears to look at some spatial analysis we did with our AFC data, our Presto data, to help operations prioritize high activity locations to distribute masks as part of their back to school plan. So as I'm sure you all know, the COVID-19 pandemic developed really quickly in Toronto. As the timeline on this slide shows, by March 17th, most employers developed a remote work policy. By March 23rd, both the province and the city of Toronto declared a state of emergency, and all non-essential businesses and schools were ordered to close. By the beginning of April, we saw a ridership decline to about 15% of pre-COVID level, with some variation by mode. So bus ridership declined to about 22% of normal, and a subway dropped to as low as 10% at one point in April. But this wasn't a surprise to those who know Toronto and how our transit system works. Our subway is designed to transport customers into the downtown core where most of the office activity happens. But on the other hand, our bus network mainly serves low-income neighborhoods and essential industries such as food manufacturing and distribution. About a third of our customers don't have access to a household vehicle, so they still relied on the TTC to conduct their essential errands, such as doing grocery shopping and going to work. And the people that relied on the TTC mostly used buses, not subway or streetcar. During the early days of the pandemic, while we communicated with the community that customers should only be using the TTC for essential trips, we knew that we would be facing challenges in maintaining physical distancing. The capacity of a 40-foot bus that normally carries up to 51 customers was reduced to 15 passengers. And our planning, which is typically based on averages for a peak hour, had to be changed and recalibrated. We were mostly concerned with the instances of crowding, and we wanted to minimize that as much as possible. Just wanted to quickly mention that since late June, we've increased our crowding threshold because of increased safety measures such as mandatory masks and also deep cleaning of our vehicles. In the early months of the pandemic, the TTC developed a demand responsive service plan, which meant a reduced level of scheduled service and the deployment of run as directed buses to fill in the gaps on corridors that were still experiencing higher demands. I want to highlight that this was very different from how we usually operate our service. So it was a very big transition moving from scheduled to on-demand service. As the economy opened up in the summer, we needed to be ready to report on overall activity, crowding, as well as deploying resources to various locations if needed. So we needed to develop a tool to help identify which corridors these run as directed buses had to be deployed to, and also to help us generate KPIs and metrics for crowding. We are one of the few transit agencies in North America that has APC on 100% of our bus fleet. So that gives us a huge amount of data to work with and enables us to produce a statistically valid daily reporting and monitoring. The tool we wanted to develop needed to tell us how much, when and where crowding was happening across the city, and the data had to be shared across the commission, especially with our colleagues at Transit Control. Working with other TTC departments and vendors, we were able to produce a daily ridership database that could be implemented into a GIS web application for visualization, which I will go through in more details in the next slide. And it could also be analyzed to produce KPIs. The data is used now to produce a daily boarding report and also a weekly crowding dashboard that we sent to Transit Control. Since May, and with the gradual resumption of activities across the GTA, we prepared for an increase in ridership and also change in our customers' travel behavior. The graph that you can see on this page shows the return of ridership as measured by bus boardings, also as well as the percentage of trips that are operated with customers above a certain threshold. And since late June, with the increased safety measures that I mentioned previously, we've been mostly tracking the orange line, which shows trips operating with 25 or more passengers on board. This is a screenshot of our APC ridership tool. It's a WebGIS tool where the APC ridership data is presented in the forms of various attributes and variables. The attributes are calculated in total and daily numbers by stop and route level, and we have the data since March 2020. The variables include number of trips at every bus stop across the city, ridership activity at every stop, trips carrying more than a certain threshold, and also sub-bay passenger loads. The variables are displayed spatially using categorized symbols, as you can see here, and also in the form of heat maps and cool maps, which I will show next. This heat map is part of our APC ridership tool and shows where crowding is happening across the city in our bus network. As you can see, we see more usage and activity on corridors such as Jane Wilson, Dufferin, Lawrence, and Eglinton. And not surprisingly, this is where we see most of our stop activity. This heat map in particular, it's been very useful for operations during spring and summer to determine where they needed to deploy the RAD buses to, as well as for our planners to develop service plans for the fall. I'll skim through this really quickly. The APC ridership tool was developed by integrating ridership data with TTC's enterprise GIS platform. The data is extracted and transformed from TTC's ridership systems using database queries and is joined to spatial objects, which can be accessed through the APC ridership tool. So as users, in addition to being able to view maps, the platform also allows us to filter layers based on date and time of the day, and also extract the data for further analysis. It also provides user-friendly interactive features such as spatial query, filters data exporting, and also historical data searches. The APC Ridership tool also has the ability to display subway demand data. We get our subway demand data for our line 1 through the Yard Management Support System, YMSS. Count of passengers is derived from the weight of the train cars, and the data that we get is available on a daily basis and is in turn used to inform various initiatives, such as the recent subway closure on line 1, and we use the data to determine how many buses are needed as shuttle buses during the closure. Measuring and reporting crowding has been especially crucial during COVID-19. Using the APC data, our team developed a crowding dashboard that you can see here. And this dashboard is used by transit control in identifying customer demand and hotspots across the city. And the data is reported on the route, division, and system level for bus routes, and is available for different time periods during the day. And it reports what percentage of overall trips are crowded beyond a certain threshold. And these are just some other ways and metrics that we report crowding on internally, ranking by route on the left, crowding by division, and a weekday compared to weekend on the right. And finally, this is an initiative that I was involved with directly and really enjoyed developing these maps for operations and support of their back to school plan. We wanted to look at some factors such as presto taps and stop activity to determine what are the best locations to distribute masks. As you can see on the maps, it shows the location of all the TDSB and TCDSB schools with their enrollment numbers. The heat map on the left, it shows where the demand is on our surface network around schools, and the map on the right, it shows activity at our subway stations. We also did some analysis using the APC data similar to this to determine if there's an opportunity to shift bell times for schools to alleviate crowding on some of our routes, and that's still in the works. This map is similar to the previous ones, but it's for streetcar only. We don't have APC on all of our streetcar fleet yet, so we use presto taps as a proxy to show demand at the intersection level to help COVID ambassadors with their mask distribution efforts. And as you can see, there is a lot of demand on a lot of activity on Spadina, along the King Corridor, and also on Bathurst. And as of last week, or November 24th, around 500,000 non-medical masks were distributed to our customers as part of this initiative. So just quickly, in summary, I showed you today some of the ways that TTC has been using ITS data and analytics to dynamically respond to demand and provide an optimal service during the recent months. We have relied heavily on APC data from our buses to develop crowding metrics, visualize hotspots and corridors that are in need of more resources. We've also used the passenger counts from our YMSS system to support in the recent subway closures. We've been asked by operations on various occasions to support with their mass distribution and other customer initiatives, and we've used Presto and APC data to do that. And overall, as we all know, the role of ITS data and analytics has been crucial in recent months because of the nature of the pandemic, and also the changing and evolving of our customers' needs and travel patterns. To continue to support our customers in the future months, We will be providing them with crowding data, which could be used by various trip planning apps, and that would hopefully in turn benefit our customers. That's it for me. Thanks for your time.
Thank you so much, Jasmine. Very interesting indeed. Okay, the floor is open for Jasmine if you have questions to her. So I have just one quick question. You mentioned quickly that you use Presto card data, use it for the streetcar. Do you also use it in other kinds of analyses, Presto card data?
Yes, so the subway map that I showed in the slide previous to the streetcar map, we also use the taps on our other subway stations to produce that map. But yeah, we use Presto as a proxy to give us a little bit more insight into the ridership for our streetcars especially. But we have had projects that we've looked into more details into the origins and destinations patterns of our customers, where most of the trips are happening across the city.
Okay, thank you. We have one question. I think Kenny Link has raised hand tool.
Yes,
So
Jasmine?
Kenny, go ahead.
Thank you, Emma. Hi, Jasmine. I got a question regarding the YMSS data for the subway train. So what kind of calibration that you need to do to relate the weight of the train with the suspension? I think the suspension of the subway train in order to tell you the number of people on board the train. How does it work? Can you give us a bit more detail?
I believe that the way it works is that the total weight of the train when it's stopping at the station is recorded, and then using I think an average of 70 kilograms per passenger, then the total weight by car is divided into that number to give us an average of number of people that are on the train at that stop. Did I answer your question?
Yes, thank you. So do you need to do calibration at the end of the line, I mean at the yard, to ensure that every day when you start off from beginning, the train is kind of like zero out, and then you do calibration again at the end of it? Do you need to do that kind of thing?
I believe so. I'm not familiar with the details, but I believe that there is some calibration involved for sure.
I see. Thank you, Jasmine.
Okay, we'll take one more question. Professor Eldarabi.
Okay, well, I have just one question. Have you thought of sharing this GIS map, heat map, with the customers? Now that we are gonna live with COVID for some time, people will have to go back to use the subway and the streetcars and everything. It would be helpful to me as a customer to see the crowding that would allow me to maybe change my times, select different routes, instead of just going to the subway station or the bus station and find that it's crowded there.
Yeah, great question and great comment. We've been looking at that, and it would certainly benefit customers. The only shortfall with the PC, one of the shortfalls with the tool, is that it only shows activity and demand on our bus network. So we're still missing streetcar and also subway for mainly line 2. And the Scarborough RT. So that's why I think as an organization, there has been more focus on developing the crowding API that could be, in turn, that would benefit our customers in terms of getting insight into how crowded their trips are going to be, and also to give them more predictive ability. So I think the focus is mostly on developing and sharing the crowding data at this point, but it would definitely would be interesting to give public the access to that tool for sure.
Okay, thank you, Jasmine, so much. We're going to move now to the third and last presentation of this session. which is going to be delivered by Howard Chang from GRT. Howard is a principal planner with the transit development group in the region of Waterloo, GRT.
All right, thank you, Amir.
My pleasure, go ahead.
Oops. Yeah, good afternoon, everyone. Yeah, my name is Howard Chang, and I'm a principal planner at the region of Waterloo, Grand River Transit. And today I'll be talking about how we use the business intelligence to better inform our planning decisions. Okay, so we're the primary transit service provider at the region, and we operate a mix of local routes, high frequency express routes. And in 2019, we added a new light rail line to our system. And we recorded 21.9 million passengers in 2019, which is a record year. Our daily boardings was hovering around 10,000 passengers during pre-COVID-19 levels. Now we are at around like 35% of that number. So to dive in, I'd like to introduce to you our transit data reporting system, also known as TDRS. It's an online reporting server that produces reports using our AVL and APC data uploaded from our conventional fleet. The reporting server is powered by Microsoft PowerBI and SQL Server reporting services. And to date, we have 30 million data records dating back to 2012. And us internally at the Transit Development Division, we use TDRS for analyzing route performance, reporting monthly system performance, and to respond to operational issues. So as we expanded our transit system, we realized there were several challenges with our previous setup of TDRS. We had a good tool in the developing reports and such, but we needed something to sort of effectively report what is happening on a broader view within our system, and primarily for our upper management, for them to easily understand what is happening. And so this could be addressed by implementing a system performance dashboard. We also have multiple data sources available, but they were scattered before, and they need to be aggregated in order to report them effectively. A case in point is our new LRT boardings data set from our new LRT line. It is in a separate location from our conventional bus fleet AVL and APC data. So that needs to be integrated in. And third, our existing reports, while they're very effective in providing the information that we need, they're not quite flexible enough to address the various specific data needs from all the various data requests. So one way to do that is to allow users to create customized reports. And that's something we added in our latest enhancement to TDRS. So this slide shows the existing data sets that we have in TDRS and some of the new ones that we added recently. So data sets like from boardings from LRT, boardings from our contracted services, Bus Plus, as well as ridership, revenue, cost of service, revenue hours, boardings per hour. So generally the high level important metrics. And this diagram shows what types of data we use and how they flow into TDRS to produce the reports. So starting from the left side at the data sources section, we have the bus AVL and APC data feeding into our on-site init data server, which itself has a direct connection to our SQL server that is hosted in the cloud. In addition to that, we also upload the operating statistics, Bus Plus, and LRT data to the cloud as well. And within the SQL Server, the data is sanitized through a series of quality assurance checks and calculated into various data sets. And these data sets produce reports through two paths. So the first path is through the SQL Server reporting service, and the second path is the Power BI report server. So more on that on the next slide. So this chart shows how our reports are structured within TDRS. On the left side, we have Power BI reports that is primarily used to communicate high-level system and root level performance metrics. And these are, the primary audience is to upper management, but also internal staff as well. On the right side, we have the SSRS reports that analyzes performance in more detail, relating to like service utilization, passenger crowding, and schedule adherence. And the primarily users of these reports are internal staff like myself. So this is our monthly operating statistics dashboard that we use to communicate our system's overall performance to upper management. It has an interactive interface, which allows users to quickly drill down from the system level down to the root level. So starting from the upper left, the pie chart shows the distribution of our boardings by service type. And looking towards the right, it shows our most important system level metrics, namely boardings, ridership, boardings per hour, grouped in 4 separate cards. And these cards allow us to quickly compare the 3 metrics through different periods, like this month, last year, how much has that changed, and the year to date. And we also have a table at the bottom that would allows us to look up the performance of individual routes if needed. So the same dashboard also houses reports showing long-term performance trends. So with this chart shows our system boardings by month. The blue line represents this year's boardings, and the red line represents last year's boardings. As you can see, the COVID-19 pandemic has contributed to a significant decline in our boardings starting in March and April. And since then, we are on a rather slow recovery curve. So TDRS also houses other reports focusing on other performance metrics. And the important thing here is we have visuals tailored specifically to each one of them. So starting from the upper left, we have gauges to show our system's on-time performance. On the upper right, we have line charts to show LRT boardings by the day. At the bottom left, we have a highlighted table to show passenger loads by hour in a day. And at the bottom right, we have a mix of pie chart and table to show boardings for our from our conventional bus routes. So diving into one of the reports, the passenger load tracker, it shows the loads across this, distributed across the hours of the day, starting from 5 a.m. in the morning to to midnight. Each row represents a route in a direction, and each column represents the hour. And this is quite useful to for us to quickly scan our system for any crowding issues. And we used it quite extensively back in April and May when we were looking at potential overloads, particularly when we implemented capacity restrictions. So to read this table, we have the trip loads shown as color-coded cells with loads over certain thresholds shown as yellow and orange. So if it's yellow, if it's more than 15 passengers in a bus. If it's orange, it's more than 20 passengers. And clicking on one of the cells can drill down to the trip level. So so for example, clicking on route 8 on any cell, you can see all the trips and the loads across the day. And you can see in the middle, there's a 12:18 p.m. trip that is somewhat busy in the noon hour. And if you click on that, it shows all the recent records of that trip in a separate table. And looking at the max load column, that trip is consistently generating maximum loads in the high 20s and the low 30s. We also have another example that shows passenger loads by stop. It helps us to identify which segments of a route are busy. We have each column showing scheduled departure trip and each row showing a stop along the trip. And the passenger loads are shown as color-coded cells, with red approaching our crowding standard of 45 passengers. So in this example, we have Route 61 serving Conestoga College. It picks up a lot of passengers along Preston Parkway in the morning. We previously added relief trips from 7 to 9 a.m., but the report tells us there's still busy trips from 9 a.m. till noon, and they're highlighted in red shown here. So in response to the crowding, we added short relief trips slotted in between the regular trips shown in blue. And as you can see, the regular trips are not as red anymore, which means that the relief trips are doing their part to alleviate the crowding. So this is what was happening last year during the fall. So fast forward to this year, we can use the same report to flag underutilized trips. So this fall, the demand to the college has dropped significantly. And the relief trips that were well used last year, they're now underutilized. So based on this information, we can look at reallocating the resources from these trips to support other routes with potential crowding issues. So in conclusion, by establishing dashboards, our reporting became more consistent, less time consuming. We have custom reports that helps us to have quicker responses to various types of data inquiries. And the new reporting visuals definitely add a valuable insight to better understanding our system's performance. And in terms of next steps, we do plan on expanding the number of users, first to department-wide and maybe eventually to an external audience. We also plan to sort of continually refine TDRS to have a more seamless user experience. And on the other side, we are also looking at enhancing the reporting efficiency by incorporating new KPIs, new reporting visuals, new data sets, and having more of our data sets uploaded automatically. Yeah, so that's my presentation. We hope our experience in applying business intelligence to guide the service planning is a useful reference for other agencies that are looking to do the same.
Definitely. Thanks a lot, Howard. Okay, any questions to Howard? Just out of like, I'm intrigued if you have any collaborations with local universities. This is a question that always comes up. How closely academic researchers, and I know University of Waterloo has a group of very active and renowned researchers in public transit. So if you can just tell us about any collaborations with.
Right. Yeah. So so TDRS started, I guess, more than 10 years ago, and this whole starting point was a collaborative relationship with University of Waterloo Civil Engineering Department, for them to develop algorithms on how to sanitize our AVL and APC data. At the time, I guess, in our data, we had a lot of outliers, and that was making the interpreting data a bit more difficult for us. So so they helped develop the initial algorithms that are fed into TDRS, including like the sanitizing of the data for outliers, and algorithms for individual reports. So yeah, that's where.
Well, that's great. That's a it's a very, I think, fruitful area of collaboration. There's a question from Wendy. How would you describe your analytics environment before going to BI, and how long did the rollout take to date?
I guess when that question is referring to the environment within our organization. Even before we implemented the latest enhancement, we have a strong interest by our management group to find ways to really capitalize on the data that we have. We're really fortunate in a sense that, for example, our conventional fleet is 100% equipped with APC, and so we had really expanding amounts of data available. And what management really wanted is to see, we have all these data sets available. Is there a way to aggregate them so that they themselves can keep track of the system's performance more regularly and more efficiently? And even more recent years, we have definitely a lot more growing interest, even at a corporate level at the region, to use analytics more, whether it's reporting or for analysis. Actually, even lately, our corporate regional dashboard is using PowerBI. So there's definitely strong interest both from internally at GRT and also at the corporate level.
It's great to know, yeah, that that's happening as well in Waterloo. So Brandon, one last question from Brandon, and then we'll go for
Howard,
the break.
Howard, you talked primarily, it was fantastic about the ITS data being used for dashboards and internal analysis. I don't think you mentioned the AFC data. How does that fit in, or what do you use it for?
AFC, can you elaborate on
sorry,
that?
smart card, the smart card data from your smart card system and your fare collection system.
Oh, okay. So within the past 2 to 3 years, we've transitioned to an electronic fare management system. So there's a separate data source and reporting system available for that, that produces reports relating to the customer fares. So right now, that system is not directly integrated with what we have at TDRS, but that is something we definitely want to integrate that as part of our future steps, especially incorporating more detailed customer fare information, like what types of fare they've used, and can we visualize it, whether at a route level to see, oh, for this route, the proportion of, let's say, university passes is quite high or low. So that is definitely on our short list as a future upgrade. And with the foundation that we have in Power BI, it makes it reporting aspect a lot efficient.
Okay,
And
thank
definitely we can open up to it a lot the audiences as well.
Okay, good. Thank you.
Okay, well, thank you so much, Howard. And on behalf of everyone, thanks to all three speakers. Very interesting and insightful set of efforts in all agencies. So I'll bring this to a close, and we'll reconvene in about 12 minutes at 3 p.m. in the last session, really trying to bring all this together and discuss really our challenges, priorities, and needs. Okay, thank you very much. And we'll talk again in 12 minutes.